In this video, we're going to look at some just very basic factoring techniques. In particular, we're looking at factoring quadratics. Later in some other videos, we'll look at some other types of factoring problems. In this video and in the next few videos, we're going to look at factoring. Now, our ultimate goal, we won't get to the general case in this particular video, but our ultimate goal will be to look at quadratics of the form ax squared plus bx plus c. What makes it a quadratic is the fact that we have an x squared term, yet no term higher. In particular, we're going to be looking at ones in which the coefficient a, which is the coefficient of x squared, is just equal to 1. These are a little bit simpler than the ones when we let a be other numbers. In order to understand this, I think it's helpful to think about what it means to factor. When we factor something like this, I'm going to multiply, you may have heard the term FOIL, I'm going to multiply the first two terms, that would give us the x squared, multiply the outer terms, that would give us s times x, the inner terms would give us r times x, and the last terms would give us r times s. Now the middle two terms here, notice both have a common factor of x, which we can pull out, and we notice that the inside term here, the middle term, has a coefficient of r plus s. So our goal will be, given one of these types of quadratics, we need to find two numbers, r and s, whose product, I've got it written backwards here, but whose product is the constant term, that's the c here, the product is the constant term, and their sum is the coefficient of the value of x. We'll build up some more difficult ones, and we'll look at some problem-solving strategies along the way. So our first goal is to factor x squared plus 12x plus 27. In order to do so, we're going to need to find two numbers whose product is the constant term, 27, that add up to 12. Okay, now I can think about several candidates. What kinds of numbers multiply to give you 27? Well, I could do 1 and 27, and I could give 3 and 9, and I could do 9 and 3. Okay, and notice I'm doing positive 27 here, and those are really the only factors that I have. Now, if I think about their sums, look at 1 plus 27. Well, 1 plus 27 is just 28, whereas 3 plus 9 is the magic number we're looking for, which is the 12. Okay, so the two numbers that we're going to want to focus on are the 3 and the 9. So let's just check it out. I'm going to think it looks like x plus 9 times x plus 3, and in each of these problems that we do as examples, we will expand it out and make sure that we've got it correct. So the first terms, x times x would give us x squared, outer would give us x times 3 or 3x, inner would give us 9x, and the last would give us 27. And when you combine the two middle terms here, you get 12. So it indeed is that particular one. For our second example, we're going to look at x squared plus 13x plus 12. Again, we need to find two numbers whose product is the constant term, 12, and whose sum is the coefficient of x, which is 13. Now with 12, we have lots of options. I could multiply 1 and 12 to get 12. I could multiply 2 and 6. I could multiply 3 and 4. I could multiply 4 and 3, and so forth. Now you'll notice that I'm also leaving out some possibilities. For example, negative 2 times negative 6 would multiply to give us positive 12, but I've noticed something about the sums here. The sum has to be positive as well, and that's going to be a problem-solving strategy we'll look at later, that if the sum, or if the constant terms is positive and the coefficient of x is positive, we'll look at only positive values. Well, now let's look at the sum of these guys. 1 plus 12 is 13, and there is our magic pair. We don't even need to check the other guys, but you can check we would get sums of 8 and 7 as well. So let's take those two numbers, x plus 12, multiply by x plus 1. First terms, we get x squared. Outer, we would get 1 times x. Inner, we would get 12x. And last, we would get 12 times 1, which is 12. When we combine x plus 12x, we get 13x. Now, we've got a little problem-solving strategy here. If you think about the previous example and compare it to this one, if all the coefficients are positive, okay, so that's the types we've been dealing with, the coefficient of x, that in this case is 13, is larger when the factors are farther apart. Okay, so our factors were pretty darn far apart, right? 12 and 1. That's going to make this middle term much larger. Okay, just take, for example, had I done something where they're really close, like x plus 3 times x plus 4, you can work this out for yourself. I would have x squared, the last term would be 12, and then the inner term would be plus 7x. Notice that the coefficient of x there is smaller because those two terms are much closer together. Just something you'll pick up as you do some practice with this. Okay, so let's look at how we would mix the signs. Suppose I have two numbers b and c which are positive. Now those, remember, are related to the coefficient of x and the constant term. Okay, remember these are positive. If I have something along these lines, remember I'm choosing two numbers whose product is going to be c. Well, in this case, it's a positive value. Their sum has to also be a positive value, so the two numbers we might choose must be positive. On the other hand, if your constant term is positive, another way I can get a positive product, remember the constant comes from a product, the other way I can get a positive product is if the two numbers are negative, and when I have a coefficient of x that's negative, they both must be negative. What if the constant term is negative? Well, in that case, the only way to get a product of two numbers that's negative, you have to have one being positive and one being negative. If the coefficient of x is positive, the quote-unquote larger value will be the positive value, and the smaller one will be negative. Now, positive numbers are always larger than negative numbers. That's why I have this in quotes. I mean in absolute value. If you drop the sign, the larger one has to be the positive one, the smaller one has to be the one that was negative before we dropped the sign. And our last case, if the constant term is negative, that means they have to be opposite in sign, but if the coefficient of x is also negative, then the negative value, when you drop the sign, will be larger than the positive value. Let's look at an example here. We'll mix it up with some variables here. We want to factor y squared plus 2y minus 15. Now, I would not recommend memorizing those rules on the previous page for the simple fact that if you can understand them, it will go a lot better for you later, and you won't have to sit there and rely on your memory. You can rely on your understanding. But in this case, I need two numbers whose product is negative, but whose sum is positive, right? The negative 15 comes from a product, the 2 comes from the sum of those two numbers. So find two numbers whose product is negative 15 and whose sum is positive 2. Okay, so candidates. Now remember that on the previous slide, I want the positive number that I choose to be larger than the negative number. So I could choose, for example, negative 1 and 15. Now if I add those two together, I get positive 14. That doesn't work for us. Other factors that would give us this would be 5 and 3 will multiply to give us negative 15, but if I want it to be a positive value, I'd have to do negative 3 and positive 5, which would give us 2, and that's the value we want. So we want x minus 3 times x plus 5. So, in this case, y minus 3 times y plus 5. When you do the first, you get y squared. Outer, you get the 5y. Inner, you get the minus 3y. And last, you get the minus 15. When you combine the 5y minus 3y, you get the 2y. Another example, we got some t's in here instead. This time, I need to find two numbers whose product is positive 24 and whose sum is negative 14. Well, because their product is positive, that means they have to have the same sign, either both positive or both negative, and then this guy tells us what the sign is. They both have to be negative. All right, so our candidates, let's think about candidates. Ooh, it's 24, that's a big one. So they both have to be negative. Well, I could do -1, -24. Well, that sum would be -25. That's no good. -2 and -12. That sum will be -14. And there we have it. Okay, so -14 is exactly what we're looking for. So our two values we're looking for are -2 and -12. So we'll do t minus 2, t minus 12. Multiply the t's, we get t squared. -12t minus 2t. The -12t minus 2t becomes -14t. And then -2 times -12 gives us +24. Okay, one more. Oh, big one here. Now I've got to really think about this one. Okay, our product is going to be -192, and the sum of the values is going to be -16. So just to sum up the product, we need to find two numbers whose product is -192, whose sum is -16. Okay, so our candidates here, we would have, let's see, 1 and -192. Well, their sum is -191. That's no good. How about 2 and -96? Well, their sum is -94. That's no good. 3 and -64. This is really kind of silly because these are just way too far off of what I have there. So let's think about this a little bit more. I'm going to multiply two numbers and get a product of -192. Those two numbers have to be moderately large. However, one of them is positive and one of them is negative. And when you add a positive and a negative, it's kind of like subtraction. And when you subtract, you're getting the distance between two values. So these two numbers have to be 16 units apart. Okay, there are some other candidates, but I'm just going to cut to the chase. If I do 8 and -24, my sum is -16. And that was the one we're looking for. So 8 and -24 are our two candidates. Okay, so here we go. I did it in reverse order, but we have x minus 24 and x plus 8. First, x squared. Outer, 8x. Inner, -24x. Last, -192. 8x minus 24x is -16x.